Good morning, guys. You get to hear me on audio today, so hope you have a good day. Today we're going to learn about complex numbers. Complex numbers are basically imaginary numbers is the key or the main complex number that we use. So that's the main thing that we're looking at today. I've got the homework pages up here. Today I assigned the homework on Clever. So the pages are here if you want to get started on anything in class, but the assignment I need you to enter on Clever. So it is an online assignment for tonight. Our goal today is to solve quadratic equations with complex solutions and perform operations with complex numbers. The problem with the equations we've done before is not all quadratic equations have real number solutions. Some of them, for example, if we're solving x squared equals -1, there is no real number solution. So on some of the problems we had last week, we did no real number solutions. Well, today, instead of writing that, we are going to write the imaginary solutions. Because the square of any real number x is never negative, to overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I. I is defined as the square root of -1, which means that anytime I have the square root of -1, I will replace that with an I. And we will see that I in italics. So if you notice the way I write it, I always kind of write it slanted as an italics I. With the online assignment for tonight, if you put in a capital I, it will count your answer wrong. So just make sure you use the lowercase I. A complex number written in standard form is in the form a plus bi, where a and b are real numbers. So sometimes we'll get an answer instead of like 3 plus 2x, our answer would be 3 plus 2i. So standard form is real number first and then imaginary second. It's just how we write it. So number one, the square root of 81. And a negative. So technically we look at this as the square root of -1 and the square root of 81. Well, we all know the square root of 81 is 9. The square root of -1 is I. So the answer for number one is 9i. So the gist of this is if there's a negative, there's going to be an I in your answer. The I accounts for the negative number that was under the radical. So square root of 56, we have the -1. 56 is 4 times 14. So -1 is I, the square root of -1. The square root of 4 is 2, and then we have our square root of 14. To write that in the correct form, the answer is 2i, square root of 14. We put the real number first. If there is an imaginary, it comes before the radical. 2i square root of 14. Okay, number three. Number three is -7 times square root of -1 times square root of 4 times square root of 3. Now, you don't have to show that much work for me. I just want you to see where everything's coming from. So this is technically -7 times I times 2 times the square root of 3. Again, you don't have to show all that. The answer is -7 times 2 times I. So -14i square root of 3 is the simplified version of that answer. Before we start solving, we're going to look at values of x and y that satisfy the equation. There's a couple that are pretty much just like this in your bookwork. And what it looks like, in all equations, they are balanced. So in this equation, there's no exception. We have the left side equals the right side. Left side of the equation equals the right side of the equation. So when I'm solving this, it says, what is the value of x? Well, 5x is equal to 35. So to solve for x, 5x equals 35. So x is 7. Similarly with your y, the y is congruent to this. So the way this looks is -20i equals yi. And if I'm trying to solve for y, I would have to get rid of that I. So basically our y is negative 20. Our y is negative 20. And when you're looking at that, you don't have to do that work. If we look at our y right here, it's the same as the number over here. Okay, so y is negative 20. If you can just look at them and say the answer, that's wonderful. So on number 5, 54 is equal to 9x. 54 is 9x. 9x, divide both sides by 9, and we get x is 6. The I, negative 1/7 y, I, and I don't need to write the I, equals negative 4i. I can write the I on both sides, but it's going to cancel anyway, so I can just leave it out. Now, to get rid of that negative 1/7, we need to multiply both sides by negative 7 over 1, or just negative 7. Cancel, cancel. Y is 28. Okay, so in standard form, the first numbers, the real numbers, are always equal to each other, and then the second numbers, the imaginaries, are always equal as well. All right, moving on. To add or subtract complex numbers, you add their real parts and add their imaginary parts separately. Now on these, when we're writing the expression as a complex number, standard form is a plus b, oh, we hate it when that happens, a plus bi. So the real number first, the imaginary is second. On these, they always put them in parentheses, so students think, oh, we have to multiply them. No, this is just the way that the book lists them. They always put the real and imaginary numbers in a parenthesis, but we can get rid of them. So it's technically just negative 1 plus 2i plus 3 plus 3i. We don't need those parentheses. The only time we really worry about the parenthesis is when we have a negative, like number 7, and we'll have to distribute that negative through. Okay, so number 6, add the real numbers. Negative 1 plus 3 is 2. And then add your imaginary numbers. 2i plus 3i is 5i. 2 plus 5i. And that is all. These are the easy ones. It's just like combining like terms. Add the real numbers, add the imaginary numbers. Okay, number 7, we have to distribute that negative through. So we get 2 minus 3i minus 3 plus 7i. Combine like terms. 2 minus 3 is negative 1. 3i plus 7i is 4i. So distribute if necessary, and then combine like terms. All right, next, this is going to be 2i minus 3 minus I plus 2 minus 3i. Okay, there's multiple terms, but that's okay. We're still just combining our like terms. So real numbers first, so non-imaginaries first. There they are. Negative 3 plus 2 is negative 1. And then our imaginaries, we have 2 minus 1 is 1, minus 3 is negative 2. Negative 1 minus 2i. All right, adding and subtracting, combining like terms. Pretty easy there. The next thing we have to do is multiply our complex numbers. So the expressions, we're still going to write them in standard form, a plus bi. I squared is negative 1. Okay, when we're doing these, a lot of times we have to simplify. And when we simplify, anytime we have an I squared term, it is negative 1. Because I is the square root of negative 1. I is the square root of negative 1. If I multiply those together, I get negative 1. Okay, so anytime we see a negative, or excuse me, anytime we see an I squared, we will replace it with a negative 1. To multiply these, the first one we're just going to distribute. 5i times negative 2 is negative 10i. 5i times I is 5i squared. Okay, we cannot leave our answer like that because we have an I squared. If we have an I squared, our answer is not considered simplified all the way. So we replace our I squared with a negative 1. Okay, so that gives us negative 10i minus 5. Now our answer has to be in standard form. So basically I need to flip-flop this. The answer for number 9 is -5 minus 10i. Okay, now the other answer isn't wrong, but I would take off probably half a point or a point if it's not in standard form. Standard form, real number first, imaginary number second. Okay, number 10. Number 10, distribute. Distribute that I, the negative I actually, and we get -3i minus I squared. Okay, which is -3i minus -1, which is -3i plus 1. So my answer is 1 minus 3i. Now I'm showing every step on these. You don't have to do that necessarily, but on these I'm just showing you since it's the first time we're doing these. Number 11, on 11 we have to FOIL it out. So let's do so. First term is -7. Outer term is 14i. Then -4i times -1 is +4i. -4i times 2i is -8i squared. Now when you're doing these, we have to get rid of the I squared and we have to combine our like terms. So -7 plus 18i minus 8 times -1. So this last number becomes a +8. -7 plus 8 is 1. So my answer is 1 plus 18i. 1 plus 18i. Okay, similarly on 12, FOIL it out. FOIL it out. So 2 times -6, -12. 2 times -2i, -4i. The inner two terms are -18i. And then 3 times -2 is -6i squared. Combine your middles and get rid of your I squared. So -12 minus 22i. This is going to be -6 times -1. So that number becomes +6. And combine it with your 12. So -12 plus 6 is -6 minus 22i. Perfect. So the key on these is foiling, and then you have to make sure if you have an I squared, you change it to a -1 and simplify. If you have two imaginary numbers, you combine them. All right, 13. We have two more here, guys. 13 and 14. 13, FOIL it out. 6 times 6, 36. Outer is -18i. Inner is positive 18i. And last is -9i squared. Now we should notice here, these are the same, so those are just going to cancel. So our i's in the middle are gone. So we have 36 minus 9 times -1, which is 36 plus 9, which is 45. So if we notice here, if the numbers are opposites, 6 plus 3i and 6 minus 3i, we actually call those conjugates, which we'll mess with tomorrow. If they are, your outer and inner are always going to cancel. And in that case, we just end up with a number without an imaginary. Technically, it's 45 plus 0i, but we don't see that I, of course, if it's a 0. Okay, so this last one, same thing. Multiply the first, 1. Outer is -2i. Inner is positive 2i. And then last is -4i squared. Outer and inner cancel. 1 minus 4 times -1, which is 1 plus 4, and the answer is 5 on this one. So if you have conjugates, which is same real number and different last number or imaginary number, 6 plus 3i, 6 minus 3i, or 1 plus 2i, 1 minus 2i. The outer and inners will always cancel, and we're left with just a real number without an imaginary. Okay, guys, your homework, like I said, it's written at the top.